Well, this deals with the third object of the TS, which is something that's neglected quite a lot. Now, I've probably got too much on here to go through in the half hour that I've got. So if you want to get a PDF, this same file here of the talk, just email me. That's my email address there. If you send me an email, I'll send you back the PDF of the whole talk, plus some other things that you might be interested in. So this talk is based partly on this book. You'll find a whole chapter in this book on this topic. The book it's based on is a 400-page book by Besant and Leadbeater called Occult Chemistry, 230 diagrams. It's available as a free download from my website, which is www.4-d.org.uk. So you can download the whole book if you want to do that. 400-page book, well worth seeing. Right, now, they reported the internal structures of the atomic nucleus by remote viewing. Remote viewing is the modern name for clairvoyance, because people don't like to use the word clairvoyance because it's been subject to all kinds of trickery in the past. So scientific people have devised another name, which is remote viewing, and that's a respectable name to call it. Now, remote viewing has been verified in Nature in 1974. Nature's a prestigious publication in science, and the possibility of only 1 in a million it could have occurred by chance. So remote viewing is without doubt established as a correct, a genuine phenomenon. Most physicists would agree that we can never get to know the internal structure of the atom, of the nucleus of the atom. It's far too small for any optical method or electron microscope or any other method to see what's inside there. So we can never see the fine detail of what's inside the nucleus of the atom. It's a permanent brick wall which blocks progress, and you'll find that physicists are saying just that we can never know, we can never see the inside of a nucleus. It's far too small. And even less we can see the inside of an elementary particle. So it's forever unknowable by any instrumental method. But there is a method of remote viewing which was used by Besant and Leadbeater, which I'll take you through now. It's also feasible for anyone to learn this remote viewing. I've devised a very easy method, which I'll digress for a minute. It's not on the syllabus of this talk, but I will, because it's so important, I will just mention it in 1 minute. This method is easier than the flotation tank, which you might be familiar with. It's also much quicker. It opens the third eye without raising Kundalini. It's a top-down method. Opens the third eye. There's no danger of activating any of the lower chakras. It automatically keeps out unwanted thoughts. It puts you into a simultaneous wide-awake state and a deep sleep. Now, that may sound contradictory. That's with respect to the brainwave output that you develop. So you can simultaneously exhibit that you're in a deep sleep and wide awake. And what you see is quite remarkable. The first time I stumbled across this, I could see very sharp images, very highly stereoscopic. Typically in a forest, the trees would be properly arranged, and when I moved past them, they would hold their proper stereoscopic positions. The method is a free download from one of these sheets you'll find in the front cover of the book. It's called Exploring the Subconscious Using New Technology. So do download that. It's a free download. The method is totally free. I'm not making any money out of it at all. It took me years to develop, and I hope some of you might have a look at it. There's no danger of raising Kundalini, disturbing the lower chakras, but there are other dangers. Be sure to read the book before you actually start working on it. I have no psychic ability, and I was astounded, I can tell you, that when after 10 minutes use of this device, I could see all these unusual things. I think that's everything there. Right, so getting back to the proper talk. There we are, well, you've probably read that now. I'm still trying to see things like metals and ceramics, which Leadbeater and Besant claim that they could magnify to an extremely high magnification. What they're doing is using, like Alice in Wonderland, getting smaller and smaller, such that the objects are seen bigger and bigger. It's a claimed ability of... What am I doing wrong here? I've gone out. I pressed the wrong thing, Darwin. Can you rescue me? I'm not familiar with this particular one. I don't know what I did wrong there. Oh, there we are. Okay.
You're on the wheel.
All right, just the wheel, not anything else yet. Okay. Right. Now, they can magnify to any extent at all. They can magnify right down to the things like a meson, extremely small particles, and see them in sharp focus, according to their book. And they got down as far as seeing the smallest particle of matter. In Sanskrit, this is called Anu, and there are 3 of these in, well, now let me go back a step. Modern physics find that a proton contains 3 quarks. That's the modern physics name, 3 quarks. They can just about determine that a proton contains 3 quarks. A proton is the H nucleus, the nucleus of the hydrogen atom. Now, Besant and Leadbeater found that each quark, of course they didn't have the name quark in those days, in 1895 they found that these 3 particles, which we now call quarks, contain 3 more particles, even smaller, and each of those particles is called an Anu, the smallest particle of matter. Very impressive. They also describe 3D space as a continuous medium in which small holes move about, which is the exact opposite of classical physics. Classical physics thinks space is empty and particles move around in it. Their observations, I've just set out 3 of them here. Back in 1895, 10 spatial dimensions, the 10 planes. That was ridiculed at the time. The H nucleus or proton, the bonding of these is with things that look like strings. They were the first people to use the word strings. You may have heard string theory in popular science programs on TV. Of course, modern physics didn't acknowledge that these people had used strings decades earlier. Going back to the background material in the universe, molecules, atoms, subatomic particles are all in an all-pervading medium, which in Sanskrit, matrix material, mula prakriti, you've probably seen that in the Secret Doctrine, I think it's mentioned. It fills all of space in the universe. Modern physics has rediscovered this without acknowledging us, of course, in any way, and called it the Higgs field. I wrote to Higgs about it, of course I got no reply. There you go. I've just mentioned a 400-page book. It's studiously ignored. The last edition was 1951, posthumous version of that book, which you can download from my website. So, I've mentioned earlier Alice in Wonderland, but without the drink me drug. So, but described by Patanjali 2,500 years ago as a siddhi, one of the many siddhi, and the CIA, American CIA intelligence unit, remote viewing group, Ingo Swan, an English chap who worked with them and has done a lot of research into this, used that method. And I've described this. This is described in this book here. Now, they observed 18 of these Anu, the smallest particle. But I should say that the Anu, if they were able to break that up, it would disappear altogether from the physical plane. So the Anu is the ultimate physical particle size, 18 of them in a proton. And however, all their work was done before quantum theory came out in 1928, and they were not aware of quantum theory. They described exactly what they saw. They saw 18 Anu, but there's only 9 actually. I'll come to that in a minute. It's very interesting. Now, quantum theory says that if you pluck a guitar string, well, so this is an analogy. If you pluck a guitar string, it's static as shown as a bar there, a line. If you pluck it, it looks like the thing on the left, like that, double. Now, we know there's only one string. This is a good analogy for what quantum theory says. Everything is rapidly oscillating, nothing's static. And you can actually hold a lens up to a plucked guitar string, and you can see the imperfections on the metal surface at its 2 antinodes, because when the string goes to one antinode, it's static for a moment before it goes back to the other antinode. It's sufficiently static for you to look at it with a magnifying glass, and you can see the imperfections on the guitar string. So one could, by analogy, say that they were looking at the 2 antinodes when they saw 18, so that there's only 9 Anu in the proton, but they saw it as 18 because they were seeing the 9 each end of the thing. Now, you may say, well, there should be blurring in between. I'll come back to that later. It's very interesting, the reason why you don't see blurring. If I do that, you can see my hand at the extremes, but you can also see blurring in between. They saw no blurring. They saw the hand there and the hand there. I'll explain to you that in a minute. I'm going a bit fast because I'm aware of the time involved in this talk. Right, so I've just told you all that. Now, the Arno were found to be shaped like a heart, a cardioid shape. A heart is a geometrical figure looking like a three-dimensional heart, if you like to look at it like that. And let me get this thing working properly. Oh, there we go. They saw 18 of these things. I can't quite get it on, but it'll do. That'll do. Now, really, there's only one triangle. There's only one triangle of 9. The triangle has got 3 and a quarter, 3 and a quarter, 3 and a quarter. That's 9. 3 threes are 9. The other triangle is caused by the thing oscillating like that. Now, you may recognise those two triangles. These are the Theosophical Society. That's the proton, or the hydrogen nucleus, these two triangles. Not many people know that. Now, going back to this, to try and explain what happens, when that triangle there goes to that one there, looking just at these two things here, you can see the chirality. Oh, chirality I have to show here. Chirality is labelled plus and minus. It's not charge, it's chirality in this case. It's just an easy way to put chirality. Chirality is from the Greek chiro, right and left hands. You can't make those congruent, whatever you do. This is always your right hand, this is always your left hand. Only in a mirror it's reversed, or in the fourth dimension it's reversed, but in our dimension it's not. But you notice that these two, the top right one has got 2 positive chiralities, 1 negative. When it flicks into that position, it becomes 2 negatives and 1 positive. The same applies to the others. That top one goes into that, and that bottom one goes into that, sort of a cross in that case. That is very impressive because it means that what you're seeing is a flick into the fourth dimension. When it comes back, if you imagine a sheet of paper with a D written on it, if you take that out of the sheet of paper and put it down again, it becomes a B. So that's a two-dimensional piece of paper. D here, it becomes a B here. By going into the third dimension and back again, the same thing applies there. If you go from the third dimension to a fourth dimension, the effect will be, it'll change all the chiralities. And then when it goes back again, it reverses them again. So that's the reason why you see no flickering. It's not like doing that. It's actually gone out of our dimension into a fourth dimension. I'll come back to that in a minute. Now, so just going back over this. They saw this in 1895, or reported it in 1895, very impressive. Only one triangle exists, the other is created by its fast rotation in 4D space, due to zero-point energy of quantum theory that wasn't even discovered when they did their research. So a proton contains 9 Arnu in 3 quarks, not 18 in 6 quarks. And the quarks are the circular shapes in that diagram above there. Now this is easier to see actually if you think of a compound like HCl. HCl is a very simple compound, hydrogen chloride. Because of the time factor, I'll zip down to the actual what they saw, and you can read this later if you want to send for the PDF. This is what they actually saw. Now this looks a bit weird. How am I doing for time? Am I halfway through the yet or?
About 5-10 minutes.
I've got 5 minutes left only.
About 5-10 minutes.
Okay, you have to read the rest on the PDF. Okay, now what we've got here, if I can, I'm not sure that I can show it or not, but HCl, this is what caused their research to be rejected for decades, because the people who first interpreted this observation, because they thought 18 Arnu was a proton, because we see only 9 and 9, they said, oh, this must be a half atom, half a proton. And because of that, oh yeah, that's fine. Because of that's an absurd thing. No chemist would ever agree to that. There are no half atoms. But because this was before quantum theory, they were unaware of the fact that that thing is going like that, like I just told you. That is the same as that. That one goes there, and it does it so fast that they appear to be two lots, like a guitar string. I hope I got that across. It's tricky. Yeah, right. The halfway up, if you look there, that's a plane of symmetry. Everything on this side that's H. That's an atom of H, not half an atom. That's an atom of H. This is half an atom of chlorine. That's what they see for chlorine. Sorry. Delete what I just said. This is an H atom. This on the left of my light, this part here, is a chlorine atom, but the chlorine is also rotating like that. And so this thing here is not chlorine. This is chlorine, this bit here, and it rotates around like that. So what you're seeing there is an H atom and the chlorine atom and another chlorine atom, which is really the same one rotated, and another H atom there, which is that one rotated. These funnels are not particles, they're just showing the arrangements of the Arno, which I haven't shown. The Arno has shown us dots in some cases, but not the whole lot. There's too many. So these funnels are not particles, they're just showing the arrangement in a funnel-type form. That's what they show for HCl. Now, let's see if I can squash a bit more into this talk. So that interpretation is incorrect. It's not H a half, Cl a half, Cl a half, H a half. So, but that's what caused it to be rejected for decades. Originally assumed that a triangle was a half atom, half a proton. All right, that's the end of that one. Now, yeah, they pointed out, of course, Besant and Leadbeater said that they're not to scale these drawings. It would require an absurdly small dot on a paper many yards square. So these drawings are squashed up, obviously, otherwise you couldn't show them properly. I've just mentioned the next point, number 2, so I won't go over that again. Astrophysics, I'll have to skip that one. It's very interesting, but I have to skip it. What I'll go on to now is this one here. This is an attempt to show all this in relation to various religions. The Christian religion in purple there, the theosophical planes on the left, Hindu religions in blue, the Kabbalistic names in black, the dimensions. Now, if we look at the lower line, the physical world, we obviously know it's got 3 dimensions there. The astral, 4 dimensions. What the mental world is 5, and finally the top one is 10. Now, I've just about got time to say this, I think, or should I not? One can relate it to the order of the Arno, but I think I should skip that because I've got something much more interesting later on to tell you first. You can always read that later if you want to. Now, this, I should have shown you this first reading. That's the Arno, remarkable, that's the cardioid. It consists of 10 strings in a never-ending arrangement like that, and that has got a chirality. There's a left-handed one and a right-handed one. You can't superimpose them, except in a mirror or in the 4th dimension. If you, like I said, a D becomes a B. Now, each of these strings, these are called strings. Besant and Leadbeater said these are strings which constitute it. Each of these strings is composed of bubbles. On the 10th, the RD plane, the 10th plane, the string has no bubbles. Next plane down, it's got 1 coil. Next plane down, it's got 2 coils. And in our 3rd dimension, it's got 7 coils. So if you look at a tungsten light bulb, that's a double coil. That's a coiled coil. So at our level, it's a coiled. Our version of the Arno, it's the same on each plane, but with more bubbles, more coils on it. Our version here is a coiled coil. Okay. That's a lightning tour of what the Arno is. I'm having a bit of trouble with this, I hope it'll... Oh, there we go. As I said, the best that physics can do is to detect the 3 quarks, which each contain 3 Arno, but no indication of any internal structure from physics. Now we come to something interesting here. Methane. Now, this is the last part of my talk. Now, in their book, they show that as the methane molecule. Let me just get that in. Yeah, here we are. Not quite. Oh, I can't get it on. Right, what they see here we know from chemistry that methane is CH4. Now, if I stand here and I put if this is an H atom, this is an H atom, and my 2 feet are H atoms, there are 4 H's here. My body is carbon, okay? 4 H's in carbon. Because these have electrons around them, the electrons will repel. So they avoid that by doing that. So that the hydrogens are as far as possible from each other hydrogen. Here they're a bit too close, but here if they do that, now by doing that, I've created from a square, I've gone to a tetrahedron. My hands and my feet are at the 4 points of a tetrahedron. But what Besant and Leadbeater said was that what you look at in methane is an octahedron. Now an octahedron, I'll just do that again. If I'm standing here like that, that's a tetrahedron, okay? My 2 feet and my 2 hands are a tetrahedron. An octahedron would require me to do this with my hands very fast, and at the same time with my feet very fast. That would make them octahedral. Now, an octahedron, imagine a 4-sided pyramid on a mirror. That's an octahedron. That's the easiest way to imagine it. That's what you're seeing here. A 4-sided pyramid on a mirror. You can just see the outline of the pyramid. They've drawn that in their diagram to show those lines, looking down on top of a pyramid. Now, I was telling you that the hydrogen, these 3 things here in a funnel, that's 1 H atom, and they see another H atom. If you want to say that oscillates to that, there are 3 there. This one oscillates to that. So it's twice, it's double what you expect. Carbon has only got 4 hydrogen atoms. If they had drawn, if they saw that and knowing they knew a bit of chemistry, they knew that carbon was CH4. If they had rejected that fraudulently, as some people have said, and drawn it octahedrally, like I just showed you, that would have been wrong, because in quantum theory later showed that you can't have a static structure, it's got to oscillate. So this was, 1 minute, okay. This is correct, and that's also impressive. Again, the funnels just show the locations of the RNO of the carbon. They're not particles, those funnels. Carbon is in the middle of that thing, and with its RNO arranged in funnels. The hydrogens are these 3 things at the mouth of each, hovering over the mouth of each funnel. But there's only half what you see of the hydrogens. For the same reason I showed you in proton, there's only 9, not 18. I think that's the last slide, so I think I've squashed it in a bit too much. Oh, well, I've told you all this, yeah. I will just show you one other thing, if I can just have about 10 seconds. These are my rough notes. I want to show you the D and the B. Yeah. Imagine a flat sheet of paper, that's the screen. If you now rotate that into a 3rd dimension and put it back, that D becomes a B. But you can't in 2 dimensions, you can never make a D a congruent with a B. Only by putting it into a 4th dimension, a 3rd dimension, bring it back. So by analogy, a 3rd dimensional object taken into the 4th dimension will come back as its mirror image, like Alice in Wonderland. In the mirror, it's not you, it's the mirror image of you. A B is a mirror image of D. That's enough. I should have stopped here.